Hello, this is going to be lesson B12, Rationalizing Denominators. Is also found on section 11.5 of your book. Example number 1 is about rationalize each denominator. What does that mean? Basically, I starting out with this expression right here, and rationalize means you don't want to have a radical on the denominator. So in order to change this fraction, what I do is I multiply by square root of 2 over square root of 2. Where did I get the square root of 2? Right here. Basically, I'm multiplying top and bottom by the denominator. Why am I doing this? Is because by doing this, I will be able to eliminate the radical on the denominator. And the reason why I can do this is because square root of 2 over square root of 2 is the same thing as multiplying by 1. And when you multiply by 1, it's like you don't change anything, okay? So like 2 times 1 is 2, 3 times 1 is 2. Basically multiplying by 1, you get the same number. So basically I'm multiplying this fraction by 1, and it's going to give me the same thing, but in a different way, in a different look. So let's see what happens. Square root of 2 times square root of 2 is square root of 2 to the second power, and basically what happens is the 2 comes out, so I no longer have a radical. And on top, square root of 2 times square root of 3 times square root of 2 gives you square root of 6. And so then my answer becomes square root of 6 over 2. And I no longer have a radical in the denominator, and that's what it means to rationalize each denominator. Okay? So here's another example of rationalizing. First of all, I start out with 2 square root of 9 over square root of 16y. Well, first of all, I noticed that I do have some perfect squares here. 9 is a perfect square, so I'm going to change that to 3. So 2 times 3 is 6. And also on the denominator, I have square root of 16, so I do find the perfect square of 16, so the square root of 16 is 4, so I get 4 square root of y. That would be awesome, except for the fact that I still have a radical in the denominator, so I need to rationalize, okay? And also one thing I did before I did the rationalization, I noticed that I can reduce this fraction, so I went ahead and divide top and bottom by 2. So I got 3 over 2 square root of y, and I still need to rationalize the denominator because I do not want to have a radical in the denominator. So what I do is I multiply top and bottom by square root of y. Once I do that, I get 3 square root of y on top, and square root of y times square root of y gives you y squared, which basically is 2y. Okay. With time, you get used to the fact that when you multiply square root of y times square root of y is y, you can skip this step. You don't have to do this step, okay? But just for the beginning, or when I'm teaching, I try to show you every single step so you understand what's happening. But eventually you become accustomed to that whenever you multiply a radical times itself, you get whatever's inside the radical, and that's what happens here. Okay. In class there was a question, and I showed you another way to do this problem where instead of doing like simplifying the radicals and reducing, I went ahead and did the rationalization first by multiplying top and bottom by square root of 16, and basically on the bottom I get 16y, and then here I did multiply. But at the same time, before I multiply, I said, oh, this is square root of 9 is 3, square root of 16 is 4, and then you have square root of y. Once I multiply these numbers, I get 24. And can I reduce this fraction? Yes, I can. I reduce it by 8, and I gave me 3 square root of y over 2y. So both ways are correct. You can choose whatever way you prefer, or whatever way you see it to get to the final answer. Okay? Alright, here was just another example of rationalization that I did on the side for the class, just showing you that square root of 5 times square root of 5 is 5 squared equals 5. Here, square root of x times square root of x is x squared equals x. And what I was trying to show is that you can skip this step right here, and whenever you have square root of x times square root of x, you get x. Okay, so and you see that from now on I try to do that. As you can see on letter C, for example, we start out with square root of 5m over square root of 11n, So the first step I did is to split the radical top and bottom, and I focus my attention on the bottom because that's what I want to do. I want to rationalize the denominator. So I multiply top and bottom by square root of 11n, and this times this give you just what's inside the radical, 11n, and on top I get 55mn. And there's I tried to do the prime factorization of 55, and I found out that it's 5 times 11, so there's nothing much that I can do, so I just leave it like that. Alright, problem D. Same thing. First thing I did is to split the radical. Okay, now this is a cube root, and the prime factorization of 25 is 5 squared. For me to be able to get the 5 out of the radical, I would have to have 5 to the third. So when I rationalize, I am not going to multiply by the same thing, but rather I'm going to multiply by whatever I need to complete the 5s over here so it can come out. So for this 5 to come out, it has to have a 3 right there. So I'm missing one more 5. So that's what I'm going to multiply top and bottom by 5 to the first. Because notice 2 plus 1 gives us 5 to the third. And what happens now? Can I remove the 5? Yes, I can. And once I remove the 5, there's no more radical on the denominator. So I'm manipulating the situation here to work in a way that there's no radicals on the denominator. Okay? And that usually happens if you have a root other than 2, where you have to manipulate the exponents now to make it work for you. Alright, on the top I got 10, and basically that's my answer there. Okay? Let's continue on to letter E. E again is a cube root. So first of all, I split the radicals as top and bottom. I notice that I have 7 to the first. I would like this guy to be a 3. So how many more do I need? I need 2. So that's what I'm going to multiply top and bottom by, because on the bottom now it makes it cube root of 7 to the third, and then the 7 can come out. On the bottom I get 7 squared and a cube root of x multiplied together gives me 7 squared x, which is 49x. Okay, remember, all our goal is in rationalizing is to get the denominator by itself. Okay, I'm sorry, get the denominator without a radical. Sorry, I misspoke there. So the whole idea about rationalizing is trying to get the denominator without a radical. Okay, so let's go on to the next one. Again, now I have a fifth root of a squared and 32b squared. So first thing I do is do the prime factorization, and I see that I get 2 to the fifth, b to the second. The 2 is fine, I don't need to complete anything, but the b I need to complete to be able to get out of it, to get the b out of the radical. So how many more b's do I need? I need b to the third power. So I multiply these two guys, and I get 2 to the fifth, b to the fifth, and on the top I get a squared, b cubed, and on the bottom now the 2 and the b comes out as 2b, and on top I'm left with fifth root of a squared, b cubed. Okay. Alright, so here was just an example where I was showing you how to complete how to complete the exponent that I was missing. So in this case I would multiply by 2 to the second to complete. Okay, so this was just a little notes that I had. Okay, alright, now that we talked about rationalizing these guys, I'm going to talk about something called conjugates. Okay, conjugates, we've seen it before. It's like one of the special factors that we work with on previous lessons. Okay, basically the special factor was a squared minus b squared is the same as a minus b, a plus b. So basically, the reason why conjugates is so important for us right now when we rationalize is because let's say I have an expression like this: square root of 5 minus square root of 3, and that's square root of 5 plus square root of 3. Basically, if we follow this special factor here, or the special rule, we know that these guys fall into this category, and according to this, basically the answer is going to be the first one squared, the second one squared. So basically I'm taking the first one and I square it minus the second one and I square it. And the cool thing about doing this with radical is because 5 squared, the 5 comes out and the 3 comes out. So what is the effect, what is the results of having conjugates? Because these two are conjugates, is that they eliminate the radical. And so I get 5 minus 3 equals 2. So whenever I have a binomial times another binomial like it, except for the sign that is a little bit, the signs that are opposite, I'll get a whole number. So for example here, this is a square root of 7 minus square root of 3 multiplied by its conjugate, which is square root of 7 square root of 3. Then result's going to be that when I multiply these two, I get 7. When I multiply these two, I get 3. 7 minus 3 is 4. Okay? Same thing happens for this guy here. You just need to be careful because 2 times 2 is 4. Square root of 3 times square root of 3 becomes a 3. And 1 times negative 1 becomes a negative 1. So 4 times 3 is 12, minus 1 is 11. So this is the property of conjugates. If you multiply a binomial by its conjugate, you're going to get rid of the square roots. So basically, then we explore these kind of problems where I started out with this fraction right here. And I said I want to rationalize. Remember, rationalize means I want the denominator without a radical sign. So basically what I'm going to do is multiply the denominator, multiply bottom and top by the conjugate. Well, what's the conjugate of 2 square root of 5 plus 1? Well, it is 2 square root of 5. Instead of plus, I put a minus and then a 1. So basically, 2 times 2 is 4. Square root of 5 times square root of 5 is 5. And 1 times negative 1 is negative 1. 4 times 5 is 20. 20 minus 1 gives you 19. And on the top, I just distribute the 3. 3 times 2 is 6. 3 times negative 1 is negative 6. Okay? So let's take a look at other examples. Okay? Here I had letter B, and I noticed that I have radicals on the denominator. And so my strategy is to multiply top and bottom by its conjugate, which is square root of 3 plus square root of 2. On the bottom is cool because we know that the radical is going to disappear, so this times this gives you 3. This times this gives you 2. And 3 minus 2 is 1. Now, on the top, we have square root of 5 plus 3 and square root of 3 plus 2. They are not the same. They are not conjugates. So in order to multiply them, we have to use FOIL. Square root of 5 times square root of 3 gives you square root of 15. Square root of 5 times square root of 2, which are the outer numbers, gives you square root of 10. The inner number is 3, square root of 3, gives you 3 square root of 3. And then it's time to combine this, but they have different radicals, so I cannot combine. So basically I just copy them down in the middle. And the last one is 3 square root of 2. Okay? And basically I look at these, and I cannot simplify square root of 15, cannot simplify square root of 10, nor 3, nor 2. So basically, there's no way to simplify these radicals, and for that reason, there's no way to add these together. There's no way, there's no one that can be combined. So basically, the top is going to stay like that. And basically, here I was kind of being a little lazy, so I just kind of said, okay, these are going to be the same as that, okay? And basically, we're going to have this on top divided by 1. Well, anything divided by 1 is the same thing. So basically, the final answer then is square root of 15 plus square root of 10 plus 3 square root of 3 plus 3 square root of 2. Okay? Alright, let's look at the next one. I started out with this fraction right here. And my focus is to rationalize the denominator. So I multiply by its conjugate, which is 2 plus square root of x. And whenever you multiply on the bottom, you have to multiply on the top too. Because remember, you gotta make sure that this is a 1, right? Because this over this is the same thing as 1. Okay, now that I'm multiplying this, the bottom is gonna be 2 times 2 is 4 minus this times this gives you x. On the top, because this is a monomial, just one term, you're gonna use distribution. Okay, so the 4 times 2 is 8 square root of x, and then 4 times 1 is 4. Square root of x times square root of x is x. There's nothing else that I can do here on the top. And on the bottom, I met my goal of not having a radical on the denominator. Okay? I think here there was just some examples of some conversations that we had in class about rationalizing the denominator. So, but this is very simple here. So, and I guess I was illustrating the importance of paying attention to the roots, because you have square roots, cube roots, and fourth roots. So that concludes the lesson for assignment B12, and here's the assignment right here. So thank you very much for your time, and have a great day. Bye-bye.